Going to perform contouring exercise. So in contouring, what we do is we take the elevations of the various ground points. So objects which we have plotted on the plane table sheet by radiation method or by intersection method, we have plotted like trees, we have plotted, we have shown the road, we have shown a building, we have shown the electric poles. So we must know the ground elevation of all the points. So once we know ground elevation, we can draw contours. Contours are the points of equal elevation. So we have to find out the equal elevations. If they are not directly available on your plane table, you have to linearly interpolate them. These contours are very important for any of the project to prepare engineering map, so that we can find out the third dimension of the ground, we can find out the slope, we can find out the topography of the ground. So these details which you have plotted, they are two-dimensional details. Once I show the contours on the top of it, then the map becomes a three-dimensional. That gives you Z dimension. So by knowing Z dimension, you can tell me whether this tree is higher elevation or this tree is at a higher elevation. You can also tell me which way the slope is going. You can also give me profile of the ground and so on. So many things you can work out with the help of the contours. So let us learn today how to take the elevations. So as we are doing leveling, so as we take the observation in the leveling, we are following exactly the same procedure to take the spot elevations of the points. So thing which you have to remember here is, suppose you are plotting this tree by radiation method, at the same time you have to take the elevation of this point and write the value here. So to note down the elevation, to take the elevations, what we are doing is we are using an instrument called level. If the ground is highly undulating, then we will use theodolite. If we are working in a mountainous area, we can use clinometer and clinophore. So same procedure we have to use. You have to level it with the help of the 3-foot screws, and once the bubble is in the center, then we start our work. So you can see that building corner has already been plotted. Now a person is standing here with the staff, so I like to focus on that. I like to read this reading, steady wire reading of the staff here. So once I take the steady wire reading, I focus the staff, I note down the 3 readings from the upper wire and the lower wire reading. I can get the distance also of that particular corner. So I will know the elevation of this point from the middle wire reading. I know the elevation of this point if I measure the height of this plane table from the ground. So you can measure the height of the plane table from the ground. So this is roughly 1.2 meter. So height of the point is known to you. Add 1.2 meter, subtract the central wire reading, you will get the elevation of the point. So very simple principle of leveling you are using. So once I know the elevation of that point, so from the reading and the calculations, the elevation of that point, this corner comes out to be 202.345 meter. So now I'll send the person to another point. Say for example that large tree which you can see. So I know now the location of this large tree. So I'll again bisect the staff and note down the reading. So I have bisected the staff and note down the reading, and the same way I can add the height of the plane table, subtract the central wire reading, and I can now find out what is the elevation of that tree. So elevation of this particular tree comes out to be 201.561 meter. So this way what we will do is we will find out the elevation of the various points by sending the staff at different locations and write the elevation value right on the plane table. You don't have to write anywhere else. You have to write all the elevation value on the plane table top. Stop. You can see that we have carried out that exercise and determined the elevation of various points on the ground. So once you get these elevation on the points, your next job is interpolation of contours. So this is very important to understand how you interpolate the contour. There are several methods. I'll explain you here very simple linear interpolation method. And linear interpolation method is based on one single assumption that the ground is uniformly sloping. What is the meaning of that? Meaning of that is very simple. For example, this is 200.9, this particular point elevation, and this elevation of this tree bottom is 201.132. If I join these 2 points by a straight line, so I can see here this is more than 200, this is greater than 201. So if I have to draw a contour of 201 meter, so that means 201 meters somewhere lie between these 2 points. It may lie here, it may lie here. It depends upon the interpolation. So I know this value, I know this value. If I take the difference of these two, I know the distance. I can make the divisions and I will immediately know that this is 201. So that means my contour of 201 will certainly pass from here. So this way we are going to do our linear interpolation. So for example, this is my point 1 where 201 will pass. This is 200, this is 202. If I join these 2 points and again find out 201, maybe 201 will pass through here. So this is 200.9, this is 202. So maybe by linear interpolation we find out another point of 201. So this is the procedure. This is 200 and this is 201.561. So again 200 may pass somewhere here, 201. So once I get sufficient number of points of 201 value, I can join this point, I can join this point, I can join this point by a smooth curve. So you have to use a very smooth curve. Now what will be the shape in between? You have to look at the topography, you have to remember the characteristics of the contours, you have to see the slope of the ground. So that is why the contours are plotted in the field itself. So you can plot this line, join this line wherever you find 201 and this becomes a 201 meter contour. Now similarly you can go for, suppose 1 meter is your contour interval, you will like to go for a contour of 200 meter, then you will like to go for the contour of 202 meter. So to find out the contour of 200 meter, again you have to see this value is 200.564, this is 199.510. So if I join them by a straight line, I'll find out a point where 200 contour will pass. Between this point and this point, again I can interpolate, probably 200 will pass from here. So I got a point here, I got a point here. Likewise, I can find out many other points and I can join them by a line. So this is the contour of 200. So I know the contour of 201, I know the contour of 200, I know the contour of. Now I can plot the contour of 202 in the same fashion. This is 201, this is 202. So if I join by a straight line, 202 will be somewhere here. This is 201, this is 202, so maybe 202 will lie somewhere here. So I know this point, I know this point, so they will definitely pass through 202 contour. And same way I can find out other points also. This is 201, this is 203. So 202 maybe will pass from here. So this line will definitely pass from there. So what will be the shape in between this? You have to see the ground. You have to remember the characteristics of the contours as well as the objects which are present on the ground. So here on the plane table itself, I got 202 meter contour, 201 meter contour and 200 contour. So this way, when you shift your plane table to some other location and you get the elevation in these areas also, you can keep on extending these contours. You keep on interpolating these contours. So this is the way to interpolate the contour. Suppose I have to get the contour of 201.5 meter contour. So I know 200 contour, 201, I know 202. So I can draw one line in between and this contour will be 201.5. So all this interpolation which I am doing is a linear interpolation. I am not using any mathematical relationships. I am using very simple relationship that ground is uniformly sloping. So I can divide the elevation difference according to the distance and can find out the elevations of the various points. If so that your interpolation is accurate, what you have to remember is that you have to take sufficient number of elevations on the ground. So that means you will not take scattered measurements of elevation. Wherever you will feel that there is a change in the topography, change in the slope, you take the elevations of those points on the ground. So there should be sufficient number of elevations data available to you on the plane table so that your interpolation is more accurate. Denser the number of points, more accurate will be your interpolation. If you are interpolating only with few points, then your contour shape may not be accurate. So this is the way we carry out the contouring in the field. And once you know the contour, then you can find out the slope between the 2 points. I know the elevation here, I know the elevation here, I know this distance, I can calculate the slope. So these contours represent the third dimension of the ground. They will also tell you which way the ground is sloping, which point is higher, which point is lower, and this will also give you the profile. Suppose you draw a line here, you want a profile along this particular line. So several contours will cut this particular line. So you can draw a profile, and profile will give you the shape of the ground, how the shape of the ground is along this particular line. So contours are very, very important to us. What is the difference between a plan and a topographic map? You are preparing a topographic map. Topographic map has a third dimension contour. A plan will have only 2 dimensions, X and Y. So in engineering maps are prepared with the 3 dimension. So that is why these maps are known as a topographic maps, because these maps indicate you third dimension, and such maps are required for engineering planning. Any developmental project, any engineering project requires the third dimension of the ground. So is that clear how to perform this particular?
Yes.